Hello and welcome back to the shop. Today I'm standing by our trusty Atlas 7A metal shaper. And the reason for that is we've got a job for the shaper to do. Now those parts we were milling yesterday on the Harrison Universal milling machine have been welded now into two stretchers. There are two stretchers which we're going to be machining for my steam locomotive, which is a 5-inch gauge London North Western Railway Super D, an 080 heavy goods locomotive. And the two stretchers which we've welded up, which we've fabricated, are for the tender. One's for the front and one's for the rear. In case you don't know, the tender was the unit that the locomotive towed, which carried the water and the coal. So we're going to be machining them. An awkward little shape. I've got the other one somewhere, here it is. This is the front one, I'll just bring it to you. That and that were the two pieces we machined on the milling machine. You can see they're all welded in now. It's not the best welding in the world, but it's certainly not coming apart. So what we've got to do is we've got to machine that top face, got to machine that face, the ends, and then we've got to machine these extension pieces here. Because on the tender there are 4 frames. There's 2 outside ones, one there, and there's inner frames, one there and one there. But that's going to be quite substantial, that structure there. I don't want any problems with distortion, damage or anything like that in the locomotive. So we're going to be machining these today, and the first stage is going to be to skim that off. We're going to skim them off. We'll do that on the shaping machine, and we might do the ends on the milling machine. We'll certainly be using the milling machine for some of the operations. It's going to be a shaper and a milling machine job. And drilling machine as well, got drill various holes afterwards. So let's have a look on the shaper to see what we're doing. We can use this as an exercise how to set the shaper up, which I think would be quite useful to you. So let's let me put that down. I'm going to bring you around a little bit closer and we're going to have a look at what's going on here. Now, I think you can see pretty much everything there. You can see I've put this is the rear stretcher on the tender. I've just put it in the vise and I've clamped it up. It's pretty even either side. That's tight now. I've knocked it down as well. So now we've got the work in the vise, we can determine how the machine's got to be set. We've got some reference point. Okay, the important adjustments on the machine. This one here, that's the table left and right. Yeah. This one here, this table down and up. Okay, can you see that there? Just at the bottom here. Yeah, you can just about see that in the picture there. Alright, this adjustment here, that unit there controls the stroke length, the overall stroke length. Directly, gear driven directly below it, you've got the offset here for the stroke feed rate, or the feed rate of the indexing of the table across. At the moment I've got it set on 1 notch on the pawl and ratchet system, which is about 5 thousandths. It'll go to about 25 maximum. But all we do is we undo that nut there and we move it on the T-slot here, one way or the other way. You can send it the other way. If you're feeding one way, you need it on one side. You're feeding the other way, you need it on the other side. And the same with it, that ties up with this here, you've got right and left. And this little lever here, you just flick that over one way and it'll feed one way, and flick that over the other way and it'll feed the other way. But what you've got to remember is every time you're using the machine, you always feed on the back stroke, you never feed on the forward stroke. The machine's got enough to do doing the cutting stroke. What you don't want to be doing is indexing on the forward stroke, and all of a sudden it's got a massive cut to take off. It wouldn't look good, and it wouldn't give you a straight line. So if you're machining up to a shoulder, you'd be actually machining on an angle because you were feeding at the same time. So that's not good. Always feed on the rear. So when you're looking at this, make sure your timing's right. You might have to move this to the other point, to the other side, 180 degrees out. Alright, but that's the adjustment for the stroke length, and that's for the feed rate. At the top here, this is the adjustment for where the ram starts its stroke from, and that's the lock. So once you determine that, you use the lock. On top here we've got a scale. Can you see that there? That's the scale. 0, 1, 2, 3, 4, 5, 6, 7 inches. At the moment I've got it set at 7 inches. But what I'll do, I'll take you back out of the way because I need to stand where you're standing now. And we'll adjust that. And we'll adjust that stroke length. You can see things now, can't you? Yeah. Right, I wanted to adjust the stroke length on this. You've got to make sure that this is at the back of its travel, furthest point on the rear stroke. That's the, if you like, the back dead centre. It can't go any further back. Then you can read direct off here what the back allotment off. Yeah. There you are. 6-inch stroke, 5-inch stroke, 4-inch stroke. Well, I know that's 6 1/4 inches, or 6 5/16. So I want to use that 7-inch. I'm going to use the full stroke. So we'll come back. There you go. It's actually just gone over, but you can't go any further because of the way the system's designed inside. Put the maximum there, okay. So that's a 7-inch stroke, and I'll just turn it over by hand just to show you. That's the stopping just in case. See, we haven't set the position where the ram will start stroke from yet. We'll get the tool set up to do that first. So you can see, there you go. That's maxed out on the stroke now. And we're coming back to that back dead centre point, which is about there. Okay, I'll just put that down there. The lock nuts for the rail are loose on both sides. I've loosened them off deliberately because we need to set the height. Now I was going to use the Atlas shaping machine tool. Yeah, we've seen that before, haven't we, that one? Or not that one, sorry, I got the wrong one. Giving you some bum steer there. That's the one we were going to use. See, Atlas Press Company, Kalamazoo, Michigan. There you are, Atlas Shaper tool. But the problem we've got, let me just go around the other side and you can see what the problem is with this. It's going to clash with the work. Can you see that? We haven't got the room underneath the tool for the work. This is the actual table's at its lowest point. You can't go any lower than that. So, what are we going to do? Well, we can do what many people do with a shaping machine. They use conventional lathe tools. And the thing is, this is a right-handed tool. Yeah, approaches the work from the right. If I pop this in, yeah, see, it's got plenty of height now. We're okay there. That would actually go in no problem. The geometry is not quite as it should be for the shaper, but it's not going to make much difference on this. We're just roughing this off. We'll get a decent enough finish with this, no problem. But the problem is we're actually feeding that way with the table. So we're cutting, and the pressure and the force is acting on the moving jaw, not the fixed jaw. We could turn this round through 180, but I don't like the controls on the back side of the machine. I don't have to keep walking around if I want to do something on the back. I like everything being here, and that's the good thing about this. You'll see everything's here. We've got the inverter drive down here, the controls with the e-stop, very important. We've got all the adjustments on this side. I like having it as it is. So I like cutting with it feeding this way, feeding towards me. And that puts the force acting against the fixed jaw, which is a better one. So what we can do, I need to get some left hand cranked roughing tools. This is a number 29, it's a solid end, it's 1/2 inch square, solid end made in Sheffield. They were excellent, excellent tool, butt welded, high speed steel tool. But what I do have is just over here, and I put it over here for a reason, so I just need to put a decent edge on it. Let me just come around. Now, can you see that? That's a knife edge tool, and it's a left hand knife edge tool. Not the ideal thing for roughing something off, but it'll do the job. So what I need to do now, you can see it's brand new, it's just painted. They just rough the angles out for you, you have to sharpen them properly. So I'll put a proper edge on this, and we'll get that nice and sharp. But I don't want the angles too sharp. And then what we'll do is we'll rough that off. You can see we put that in there. We've got plenty of height now. That's not a problem. So we'll use these. So when people talk about the 7-inch shaper, 7-inch stroke shaper, what they mean is it's got a 7-inch overall stroke. Well, the theory is that if you have, for example, a 7-inch shaper like this one here, you could actually shape a cube 7-inch by 7-inch by 7-inch. You can see we haven't got enough space there. I mean, what's that distance underneath the clapper? You're only 6 inches there now. So even if you were direct on there, it's just a theoretical size. If you have a 30-inch stroke shaper, it'll do a 30-inch stroke, but whether it would do a 30 by 30 by 30 cube is, well, very doubtful. But imagine the weight of a 30 by 30 by 30 inch cube of steel. You know, you'd need a substantial bed. You really should be doing that on a planer. But anyway, let's go back to our little shaper. You'll see on this here, this is an early machine, a 7A, different from a 7B. 7B had the table support at the front. That was the big difference. It had wipers on the ram. I think it had wipers on here as well, on the table. Wipers on the other side. And instead of 3 grub screws, it had 4. There's probably other differences as well, maybe in bushes or something like that, or the bearings. I know they tapered all the bearings in here, but the shaft at the back here, that's needle roller bearings, and it's needle rollers in that one as well. I don't know if they were ever changed from the later machines. But anyway, I made a difference. I've changed this something. I put a little lock on. That's my lock for the tool slide. A simple little device to make. Locks up against the gib strip, and that locks everything in position. You don't want this moving when you're cutting. Alright, so what we're going to do now is I'm going to sharpen that tool nice and sharp, and I'm going to put it in, and we'll set everything up with the tool. And then what we'll do is we'll have to set the position where the ram stroke is going to start from. So let's do that, eh? Alright, just sharpened the tool. A nice keen edge on that. Feel right that well. Just put it on the offhand grinder there, the bench grinder, and the oil stone as well. So, I need that and that. Let me just go around here. Alright, we'll put this tool in. See, but because of the size of the slot here, I need to put a packing piece in here. And we've got one bench over here, which is specially made for the task. So let's put that in first. That's in. Should be alright. Let's just move that. Just check the angles. Just move that slightly away. Okay. We're not doing up to any shoulders or anything like that, so it's not that critical. What is critical is that we have the clearance of relief that way. So when we cut it across, it's not rubbing on the back edge. Let's just make sure that's tight. Right. So there we are, we've got our tool in now. And we've probably got a good 1/8 of an inch clearance over that weld there. So we've probably got plenty. Alright, what we're going to do now is I'm going to put my glasses on so we can start getting the thing set up properly. And we'll need to obviously take a pass across just to find out where our start point's going to be. We'll have to set the height and all kinds of things. In fact, what we're going to do is we can't, as you can see, we can't really do anything more with the height. So what we're going to do is to the bottom of its travel now. I've just taken the slack off here on the screw. And then we're going to tighten up these nuts first before we forget all about it. Clamp this up. Pulls all the slack out of the table, out of the cross rail, sorry, and then we know it's not going to move. If you leave these undone, you're going to have problems. Slacker in the thought. Let's do the other side. If you read the manual from Atlas, it tells you you've got to do this. Every time you lift the table up and down, and this is even on the 7B, you have to lock the cross rail in position. And if you're at the 7B, what you'd have to do is you'd have to adjust your foot at the front, which you did adjust it. Right, down there. Alright, what we need now is glasses, which are on the shelf behind us. Alright, let's just have a look to see where that stroke starts and finishes from. Can you see all right there? I think you can. It's in jog facility now on the control. He stops out. As long as my finger's on the button here, it'll go. As soon as I let go, it stops. See it overrunning the front. We need more overrun at the back, so we need to adjust this position here. So we're going to undo that, the lock. And what we're going to do is we're going to move it backwards a touch. We're going to lock it, and then we're going to try it again, just see what it looks like. I mean, there's various schools of thought as to how much you need to overrun. You don't need to overrun by a massive amount, but you need to give the tool sufficient time to reset, especially on the return. And you don't want to have it so it's absolutely maxed out. So this is right on the end when it stops, and it's travel, and it stops right on the end there. You're still cutting with full force across the whole thing there. So you've got, if you think about it, on your yoke, it's running around, is a bit like a crankshaft. You've got your forward dead centre and your back dead centre. You're not actually pushing it forward or back, it's stationary in that respect. So what happens is that you can have maximum force, you're going to do some damage in your machine. It needs to start coming around through the arc of the cutting stroke. Once it starts moving past that forward and back dead center, you can start applying the force. So you need that gap front and back. Let's try that again. There you go, it's alright. See, there's less at the front now. A bit more at the back. Let's just check how it looks from the front. I'd sooner have more at the back than at the front. That's not bad at all. I think we're going to leave that there. We're not taking off a 1/2 inch cut or anything like that. Maximum we would take off be about 50 thousandths. So it's very comfortable with a 50 thousandths cut, this is. Alright, so we've got our stroke length is set. We've seen how we do that with this right back at back dead center. We've adjusted where the stroke starts from. What we need to do now is we need to check to see which way this is actually feeding. Okay, so what we're going to do is we're going to just put a normal run, and I'm going to let it just keep continually stroke, and we're going to look at this now. Alright, let's see what happens when we engage. See that? That's feeding now on the front stroke. Look, can you see that turning? You don't want that. Hear the click. Now it's feeding. We don't want that. Let's see what happens when we do that. That's feeding on the backstroke now. But is it feeding the right way? It's feeding that way. It's feeding away from us, that's no good. So what we've got to do is we've got to move this in the slot to the other side here. So what we'll do is we'll stop that. That'll do. It's a bit stiff at times. Better. We'll see what that's like. It's the neutral. Not feeding there. Now it's feeding. And the backstroke. It's feeding 2 clicks, which is about 10 thousandths. Don't want that. So what we're going to do is we're going to make an adjustment to this. Stiff at times, this bloody thing is. Let's just see what that's like. And now it's feeding now. Not feeding. There you go. Right, so that's set now. neutral position. I always store this down here. Alright, what we're going to do now is we're going to touch off. You see the weld here, they're the highest points. We want to touch off on them. So what we'll do is we'll bring that across a little bit. Right, let's get a nice speed, undo the lock. That's it, let's touch that bit there first. Alright, so let's just lock that. Let's move this across. There's no point winding it all the way across because we know where the highest bits are. What we'll do is we'll put ourselves in there. It's a 25 thousandths cut there. Do 50. And we'll lock it in place. Just bring it a bit further across. A bit more clearance. It's running at about 800 RPM on the motor. We can count the number of strokes per minute, but it looks alright for the size of stroke. That's the important thing. Can you see that working alright there? You know, the rails are all locked up. We've got the stroke rate sorted out. Right stroke length, start of the cuts right. Let me get my oil can. Just put a globule of oil on there. Starting now. Could go a lot faster if we wanted to, but I don't want this dancing across the floor. Nice, steady, controlled speed. Touching in 2 points now, there and there. Just put a little bit of oil in here as well. On the other side. I only oiled this yesterday. It retains oil pretty good now. Now that we scrape the ram in, just give us a bit of a spurt in here. That's doing alright, that is. Sometimes while you've welded it can be really hard. You could use a carbide tip tool, but I wouldn't use one on this sort of stuff. You're just damaging it. There you go. Let's bring it back. And 50 on. There you are, we didn't move it across sufficiently there. Switch. Hello, welcome back to the shop. It's the next day now. After that little faux pas last night, I decided to call it a day and I went to get something to eat and I didn't feel like going back in the shed after that. But anyway, I've already had a check on this here. There was no damage done at all when we saw that little crash with the tool there. What actually happened was that I wound the work across and I didn't move it far enough and I screwed this in. I was too keen to put my cut on and it jammed in on a piece of the weld and it tripped out. So what it did is actually tripped on the inverter and I was really impressed with that. How rapid that reacted. That was really good, that was. I've used inverters, I've worked with them in the past and they are exceptional reaction times. But it was good to see that was. That helps prevent damage. But could you imagine if this was a big shaper, like one of these big Cincinnatis or Ohm rods or G&Es or something like that, and it was, you know, a 32-inch stroke, 36-inch stroke, and you'd got it maxed out in that hand. Wow. That wouldn't be nice. But anyway, what we need to be sure of is that everything's tight and nothing's moved. If you were working in a factory somewhere and you come back to a machine like this the next day, I'd have a good check over it because you don't know what somebody might have done with it. Somebody might have just been fiddling, messing around, put a bit more cut on, doing this, that and the other. You started thinking it's where you left it off and whoa, and you got major problems. But anyway, what I'm going to do is I'm going to have a check over it, going to make sure everything's tight. We've got no issues. I know nobody's been in here, so there's only me, but I'm going to move things out the way and just check it a little bit. Let me give that a thump. Just make sure it's down. Yeah, that's not riding up or anything like that. Just don't you see it. One thing, I don't have the proper Atlas handle for the shaper. It's 3/8 square and it's a forged one, it must be forged. Never ever get the cast ones. They could always break off and put your hand over. When I was an apprentice, my mate Kev, we were both working on shaping machines, and on his machine, the crank handle, it had broken off. I'll just show you. I've got a 1/2 inch square one here, and it had broken off on the end here. And somebody had welded it up, obviously not done a brilliant job. Anyway, he was tightening the vise, and he got his hand like that, and the thing gave, and it ripped all the skin up here in his hand. And he had to go to hospital, get stitches in. But anyway, like I say, I don't have, and that's a forged handle, so cast ones I would stay well clear of. I wouldn't touch them at all. But anyway, that's your choice. What you do is up to you. But anyway, when I bought this vise, I bought the vise separate, and I've got other tools and equipment for it. I've got the proper Atlas centers down there. I've got the rotary table down there, and I've got one or two other bits and bats. Can't think now. But anyway, this is actually a key for one of the lathe tools. Now, let me have a look, one behind you there, just on the shelf behind you. Yeah, can you see it's like one of the lathe tools? Fits in the top there, 3/8 square. And this came with the vise when I bought the vise. So I used this, but it's not really a proper thing. What I did find from a company called RDG, the people who own Myford, is if you look on their website, they've got a key, and this is one of them keys you use for tightening the tools up on the tool post on your lathe. It's actually 10mm square, but it's perfectly 3/8 square. There's virtually nothing in it, look. That's really useful, that's steel that is as well. So it fits all these things if I need it to. So that is really useful. It wasn't that expensive either when I bought it. But that's been very good. And I bought it particularly for the tool post here. And this is an American tool post, a lantern type tool post. Where you had the English style tool post was like a clamp that just went round. It was really a crude affair, very heavy duty, very crude. Of course, when the American type came along, it was sort of replaced all them. But yeah, I bought this for that because that's 10mm. I couldn't get a 3/8 UNC square-headed bolt like this, high tensile bolt. I use the ones, these are ones that you use on the lathe tool post. You've seen them, haven't you, where you've got the square and you've got the 3 or 4 bolts on each side, put your tools in, tighten them down. But that's really useful, that is. I think I prefer use that than one of the crank handles. There's a company called Martin in the United States who makes this handle. In fact, I actually bought this from their distributor here in Britain, and it says Martin, United States of America. So anyway, this is 1/2 inch square, as I said. On the Martin website there's one which is 3/8 square, but they won't supply it here in the UK. One here, this 1/2 inch one, I never used it. I bought it for something in the past and I can't remember what it was for now. It just sits on the bench, it's like a bit of a paperweight, that is. Right. Happy with that, that's okay. Looks alright. Turn that back down there. I'll put my glasses on and we'll get going again. We need to be careful what we're doing for this, because if you look at the amount of work we've got sticking up above the vise, it's considerable. Let me just have a look what depth we've got in the vise. Now we've got probably about 3/4 of an inch in the vise, but we've got 1.25 inches sticking up above the vise. We've got a lot of leverage there. We need to take that into consideration. We don't want to be taking too heavy a cut on this, so I won't be. But anyway, let's just see what it's like. Now I'm switching on. There we are, we've got some power on now. Let's just run it backwards and forwards, make sure everything's okay. We're in job mode at the moment. There we go. I know we aren't, but we're just on one there. Jog is there. That's one. Right, what I'll do is I'll bring you in a bit closer and you can see a bit better what's going on. But we've seen this sort of thing before. I won't bore you with tons of footage of that just going across pass after pass after pass.